appreciate everybody showing up today and giving a listen, and also you have a chance to ask questions as well. Um, I started my journey as an amateur astronomer about 35 years ago. On my own, I just decided one day that I wanted to pursue it hands-on, and so I bought at the time a very small what's called an Astroscan. It's just a 4-inch mirror, very short tube, and maybe 300 millimeters focal length, 400 millimeters, very short tube, very wide field. So you can see huge, chunks of the sky at one time very easily. And it was very easy to use. There's no electronics, no batteries, no tech, anything like that. So the Astroscan is how I started. And I went out into dark skies. And at the time, there was no computers. There were no computerized telescopes for consumers. So you had to go out and learn based on star charts, all the constellations and where they were and the objects in those constellations. And that's exactly what I did. I would go out whenever I had time to dark skies and learn the night sky. And I did that for a number of years, and finally got very familiar with most of the things I wanted to look for and where they were and all that good stuff. And then started upgrading my telescopes to get them more powerful, more light gathering, greater magnification, et cetera, et cetera. And eventually telescopes that could track with the motor. And that was it, basically, up until the point where I am now, just increasing and adding to the types of scopes that I have. So it was a very humble beginning because they didn't have the technology that we have today, nowhere near it. So ultimately, that got me to the point where I am now. And I've always been what's called a visual astronomer. I never started out wanting to do astrophotography. That's not really my thing. I like the visual. I like being able to look into the eyepiece and see the object in real time. That's where, to me, the wonder of the cosmos comes in, is being able to see with your naked eye in real time these objects in the sky. And it's led me to where we are today with the unistellar EV scope, the one I'm standing next to with the red shirt. That is the newest type of telescope that's out on the market now. It's been out for about 2 or 3 years. I represent the company, and this is the EV scope 2 that I'm standing next to. They also have a new one that just came out called the Odyssey, which is brand new this year. And these are imaging telescopes. So basically, they're a 4-inch mirror and very small, very compact. The magnification is digital, so your objects are fairly large. The telescope works with GPS on your phone. It's able to align itself with the night sky stars without you having to do anything else. It takes about 10 or 15 seconds or less. And the telescope will not only go to with the catalog of objects that it has stored in its computer, it will also image by layering the light of those objects very, very quickly, within 3 to 4 minutes. And you can see those objects in the eyepiece of the telescope. Again, you're watching in real time. And they'll also do that in the middle of the city. So you don't have to go to dark skies to actually make it work. It's an amazing piece of equipment, which is all now, 21st century optics. This is where we are. So, and that's what I'm doing now, is pursuing using that telescope. I still use the optical scopes as well for the planets and the moon and things like that. This telescope is designed for deep sky objects. So that's how far we've come. That's how far I've come in this journey. In that telescope in particular, the Unistellar telescope, I had the opportunity to work with NASA on their Lucy mission, because the company that represents this telescope also has a program that they call the Citizen Science, which is basically missions that you can operate or participate in when they list them on the database. The telescope works off of a cell phone app, so you have everything in your app on your cell phone. There's no lenses, no eyepieces, there's no finders and things like that. It's just that what you see in the picture, that's it. And so they'll send you, in the Citizen Science program, they'll send you missions. So it might be a near-Earth asteroid they want you to track. It might be an occultation, like what I did for the Lucy mission using this telescope. And you can participate in that They'll give you the instructions. They'll give you the settings for the telescope, and it's not terribly complicated, believe me. My preference for a learning curve is a rock with a light switch. That's what I like to work with. As far as a learning curve goes, I like it simple and easy. I'm not going to Caltech to learn how to, to get a degree. It's just, it's relatively easy for a consumer to participate in, and their support system is very good. So that's at the top end of, you want to get into, looking at images. You can download the images that the telescope captures to your cell phone or to your computer, and you can manipulate them in programs that Photoshop and things like that. So that's what this piece can do. And you see there's a picture of me sitting with a Dobsonian. That's one of my Dobs. So some of the objects that I captured with this telescope, I'll run those with you right now, and I'll go over some of them, just a couple of facts and details. On the left, you see that big, huge image on the left, which is the Andromeda galaxy. Andromeda is about 2.5 million light years away. It's the closest galaxy to Earth, and it will collide with the Milky Way in about a few billion years. It's 110 light years, 110,000 light years across, and it's moving towards the Milky Way at about 68 miles per second. To the right is the Whale galaxy, which is a pretty cool galaxy. It's got a shape. It's actually a spiral, and we're looking at it edge on, but it's got a sort of a oblong sort of shape to it. And when astronomers look and study the edge on galaxies, the spirals that are seen edge on, they like looking at those because they can also study some of the star formation in the galaxies because of the angle at which they're looking at the galaxies like that. So sometimes they like studying those. And you can see the little tiny fuzzy ball next to it is a companion galaxy. A dwarf galaxy is what they're called, a dwarf elliptical. Ellipticals are usually round as opposed to flat spirals. So next one. The next one's got. On the left is that's the Pinwheel galaxy with a supernova. This supernova was discovered in the summer of 2023. I was able to capture this from my backyard. It's the Pinwheel galaxy, and the supernova is that big white, dot there. That's pretty bright. That nova outshined the entire galaxy when it went off, which is typical with supernovas. 21 million light years away is this galaxy. It's classified as a type 2 supernova, which means that the star produced between 8 and 40 times the mass of our sun. That's how big it was. And it can shine, like I said, brighter than the entire galaxy. The nova collapsed. When this nova collapses, it'll either create a neutron star or a black hole. I'm not sure which. So moving on. Oh, to the right. To the right is the Whirlpool galaxy. And the Whirlpool galaxy is right off the handle of the Big Dipper. If you look at the handle of the Big Dipper, the very last star in the handle, the Whirlpool is very close. You put your finger up there. It's about the width of your index finger from the last star. And it's basically has the main spiral, and then has a smaller spiral, which is basically going to be orbiting that galaxy until it spirals all the way into it, and they both combine to make one galaxy. This galaxy is 23 million light years away. It was the first galaxy to be classified as a spiral. And again, it will eventually, the small one will merge with the larger one. And contrary to what people might believe or think, the stars aren't going to be banging into each other on a regular basis. They more than likely miss each other. There's a lot of space between the stars. So one might think that they'll all merge and start colliding with each other like the balls on a pool table. That's not going to happen. But what will happen is the gas will be heated up in that main spiral of the galaxy. There'll be a lot of heating up of gas, which could cause more star formation over time in that galaxy. And eventually, both of the centers of those galaxies will merge as well. It's going to take a heck of a long time for that to happen. But there you go. And in some cases, some of the stars in that galaxy, because of the merger, some of the stars will be flung out of the galaxy, and they'll become free-floating rogue stars. So they'll be, because of gravitational effects, they may be flung right out of the galaxy into deep space. Okay, the next set of pictures. To my left, that is the Fireworks galaxy. Fireworks galaxy is called that because there are a great many supernovas that have been spotted in that galaxy. About 10 over the last century have been spotted in that galaxy. thus the name the fireworks. It's a medium-sized spiral about 22 million light years from Earth. And to the right is M22, globular cluster, which is in Sagittarius, the constellation Sagittarius. Fairly easy cluster to find in dark skies because it's pretty big and pretty bright. It's about 10,000 light years away, contains 83,000 stars. It's one of the closest globular clusters to Earth, and it's one of the first of its kind ever discovered. The clusters are globular clusters in general, some of the oldest objects in the universe, having been formed as far back as 12 to 13 billion years ago. So this cluster contains two stellar mass black holes, by the way. And strangely enough, this cluster also apparently has 6 planet-sized objects that have been detected in it that aren't orbiting any of the stars in the cluster, and they don't know what they are. They don't know what those objects are. So that's 6 planet-sized objects that have been detected in this cluster that are not orbiting stars, and astronomers do not know exactly what those objects are. So that is in M22. Okay, the next set of pictures. Right, this is on the left, the Omega Nebula, and the Omega Nebula is an emission nebula. So that's overall, it's an area of gas and dust that expands about 40 light years across in size. And it may be the second largest star forming region in our galaxy. It's amazing how many stars can be created from these. And some of the youngest stars in the galaxy, on average, only 1 million years old. So the nebula's glowing gases in this emission type nebula are caused by radiation from young stars that are being born and interacting with the gases. And in other cases, it's because of the heat of those gases that causes them to glow. And some of the chemicals that are located in these galaxies are sulfur, nitrogen, oxygen, and hydrogen. Those are some of the gases that give you the different colors in the nebulas. To the right is the Eagle Nebula, and the Eagle Nebula is again an emission nebula, and it's about 55 to 70 light years across, and they are the result mostly of stars that have exploded and prior to that have left these gases in place. Sometimes they're left over from the formation of the galaxies. They're just big areas and pockets of gas and dust. And like I said, either they will glow because of the hot gases that are there in place, or they will glow because of the stars that have been formed within them. And as you can see in the center of the Eagle, which is captured on the telescope I was talking about, are the pillars of creation, which the Hubble imaged very, very close up. But you can see the shape, even in this image here, you can see the shape at the center of the pillars of creation, where there's a lot of star formation occurring. The next set. To the left is the Dumbbell Nebula. This is a planetary nebula, which is different than an emission nebula. The planetary nebula, this one is 1,200 light years away. The planetary nebulas are the result of a star about the size of our sun, the average size star, that has shed its outer layers of gas. When the star goes through its death throes, it becomes a red giant, which means its rim, the circumference of the star, expands way out and beyond the orbit that it inhabits, which could be 1 or 2 planets out. Our sun could do the same thing, and it could come out as far as Earth and swallow Earth on the day. And then it'll shed all of that gas and dust and become basically an emission nebula. And once again, the gases that are produced are sulfur, nitrogen, oxygen, hydrogen. That's what gives this nebula its different colors. It's about 1,200 light years away. And what's left over from this is the dwarf star. The dwarf star in the middle, the radiation from the dwarf star is what causes the planetary nebula to glow. That's what gives it its glow. So it's the radiation from the very small, very dense dwarf star that's left behind. A teaspoon of that could weigh, I don't know how many tons. So, and that will go on for millions of years. That star will stay there as a dwarf star until it eventually burns out. To the right is the comet Neowise. I imaged this with also the Unistellar telescope when it was close to Earth. And it was the head of this comet is about 3 miles in diameter. It's a long period comet, which means it's 4,000 years inbound to the sun and 6,000 years outbound. So we ain't going to see this thing for quite a while. Again, but it was very cool, and they move at a tremendous rate of speed. Anywhere from 26 to 28 miles per second, which is dang fast. So we don't want to run into any of those. On the next frame, what do we have? This is the asteroid Nereus. This is a near-Earth asteroid, which my telescope captured, and it was seen not that long ago. It's an Earth-crossing asteroid. The diameter is about less than a quarter mile in diameter. There you go, right there. When you make multiple exposures of the asteroid with the telescope, it's 3 sets of about 40 minutes each. You send the data and download the data to the company, Unistellar, and they will crunch the numbers and send you back the video that's produced as a result of this image that you've done. So it's about 3 exposures of anywhere from 40 to 50 minutes a piece. Very easy to do, very simple to set up and operate and execute. And then you get a nice movie of the asteroid moving through the background of space. So it's very cool. And the next movie that I'll show you, which is extra cool, I think it's I've got the occultation coming up. Let's see if that's going to be next. Yeah, and like I said, there's the asteroid. And the next one, this is an occultation. This is what I worked on for the Lucy mission. Okay, watch carefully. You'll see the light curve at the bottom, that little ball bouncing as it gets to the center. That's where the asteroid crossed in front of the star. You see the star disappear, and then you'll see the star reappear right there. Okay, and that's what the telescope can produce. Not only visually, you can see it, but also the light curve on the bottom. So it'll just repeat. It'll do the same thing over again and again. You can watch it again as it happens. Watch the light curve on the bottom, the little ball that's bouncing. Once it gets to the center, that's the moment it will transit the star and block the light of the star. And there it goes. And then it comes back. Okay, it took about 4 minutes. It was a 4-minute exposure by the telescope. This is an occultation. This was done for the Lucy mission, which is now in progress by NASA. And the Lucy mission, basically, they sent the probe to explore and observe the Trojan asteroids. A Trojan asteroid is an asteroid that is in Jupiter's orbit. It's not in the asteroid field between Jupiter and Mars, where most of the asteroids are. These asteroids are in Jupiter's orbit, and they believe that they were captured during the early formation of the universe. Early formation of the solar system. These asteroids might have been captured by Jupiter's gravity and caught into that. And so these asteroids may be composed of different materials than the ones in the asteroid belt. That's why they want to study them, because they're from a different source than the ones that are in the asteroid belt. And so now the Lucy mission, that probe will fly right by all of these asteroids. It's not going to stop. It's just going to fly by it, and it will image the asteroids. What NASA wanted to do before they launched the mission, they asked us who had the unistellar telescopes to do the occultation, which is when the asteroid crosses in front of the star and blocks out the star's light. That casts a shadow on Earth, just like a total eclipse, only tiny. And so it happened to be crossing right over Los Angeles, where I was located. So they asked me to go ahead and do it. And that took about 4 minutes. I set it up just down the street from where I live. I set up the telescope. I did a 4-minute exposure of the asteroid and caught it crossing in front of the star. And it was done. It was very simple and very easy to do. And then I send the data. You download the data from the telescope. You just download it on your Wi-Fi at home to the company. And again, they crunch the numbers and send you back the video along with the light curve at the bottom. So you could actually see the occultation take place visually. You can't see it in the telescope because the asteroid is too faint. So the telescope can catch it, but it's too tiny and too faint in the city for me to be able to pick it up. So this is how this again, the capability of this telescope. And by the way, you can get the same light curve with this telescope if you want to image an exoplanet around another star. It will also do that. So I can capture the transit of another planet around another star the same way. Now that takes, 2 or 3 hours or more of exposure to get that to work, to make the exposure, but it's a lot, it'll actually do it. And you'll get a light curve again at the very bottom to show where the actual transit took place. So it's very cool what this telescope can do. And the citizen science program, as I said before, with the unistellar community, as it were, allows you to participate in these missions, if you want to call them, when they come up. So they're looking at near Earth asteroids, they'll look at comets, they'll look at occultations, they'll look at exoplanet transits. So you have all these opportunities to actually jump in and do a mission with this telescope and to participate in it, and then you get the results that they send you when it's all done. It's really very cool. I enjoy using it and doing that when I have the opportunity to do so. I think that was the last image we have. Is that correct? I think it is the last one. Yes. Let me discuss just briefly for those of you who want to start, out in terms of astronomy. If you're just getting started, what I suggest is starting out with something very small and very basic, very easy to use. Give me flip through these images, if you will. Let me see if I can find this. There, that one there. This is what I would suggest if you're just getting started and you want something that's easy to use. This telescope right here is fairly easy and basic to use. You can see also it's very reasonably priced at around $200. And this is a Maksudov. I still have one of these types of telescopes that I own and I do use every once in a while because it's so small and so portable. It's called a Maksudov Cassegrain. Now, these are better than the Schmidt Cassegrain models because they have a secondary mirror in front that does not need to be aligned. You don't have to columnate it with the primary mirror. You don't have to make adjustments on it. So it's almost always going to be sharp and crisp, and you don't have to align it. It's also very powerful for the size. This telescope right here, it's just a tabletop telescope. You set it up on a picnic table or a very sturdy table, or you can get a tripod and mount the whole thing on a tripod if you want. It'll pop off of that deck, and you can put it on a different tripod as well if you'd like. So this little Maksudov will allow you to easily see planet Saturn, and you can pick up one of its moons. That's how close it'll get. And it's only $200 plus in change. You'll get a couple of eyepieces that are really, really good to go with it. They'll send you 2 eyepieces as it is, and probably a good finder also. So this is a very good scope. One of the types of scopes you can begin with to look at the planets and the moon. You want to start off, if you've not done anything at all, hands-on, just start off looking at the easiest things, the things you can see with your naked eye, which are going to be individual stars, planets, and the moon. And if you get a filter for the front, you can look at the sun as well. But at least the planets and the moon, you can look at almost most of the year round. And once you have, the familiarity with the scope and the knowledge to be able to look at those things and find them easily, then you can move into the individual stars. There are some nice double stars that you can find and things like that. You can start with the basics, and then you can go into dark sky things where you can go out in dark skies and look at other types of objects that are big enough and bright enough for this telescope to work. And that's going to be using today, instead of using a paper star chart, you can use the cell phone star charts, which are very cool. You can use those as well. Try the next one. Let me see if I can see what I have on here for. This is also just a slightly larger version of what you just saw. It has this is a regular Maksudov Cassegrain. Explorer Scientific makes it. And this is the tripod telescope. There's going to be an eyepiece or 2 in there. And it has worm controls, so you can actually center the objects very easily just by turning those little worm gears. Very easy to do. And so it's all manual. It's equatorial, which means when you set up the tripod, you point the base of the tripod towards the North Star. That way, when you track, you're only tracking in one direction. So you only have to turn one of those little dials, whenever the object might drift out of the eyepiece. And that's very easy. This particular model is 4 inches in diameter. The other one we just looked at, I think, was 3.5. So this is a little bit larger. It's going to allow in more light, and it's going to have a little bit more power. So there's your, again, this is a good beginner setup to get started to look at some of the sharper, brighter objects. You can look at Orion's Nebula. You can see that. You can see the Andromeda Galaxy with it. The Pleiades will come in very nicely, and double stars as well. So there's a place to start. You can also look at globular clusters with this telescope in dark skies. You can look at globulars. They look very nice in this. What's the other picture I have? Let me see if I can get some more of the beginners. This is a tripod that it's a tracking tripod by Skywatcher, and you can set up a telescope like I was just showing you just a minute ago. You could put it on this, and it will track for you. It's got a motor, and a small battery will drive it, and it tracks for you, so you don't have to do any adjusting to keep the object centered. And that's something you can look into as an option, an accessory later on with the telescopes you have. What's the other picture we have? I had a picture earlier. The eyepieces that I like to use are flat field eyepieces. These are very inexpensive, and I like them. They're not the best high quality glass, et cetera, but they have a wonderful field of view. When you look in the telescope at the object, it's clear all the way from left to right. Everything stays focused. So you don't lose the focus of the object as it gets closer to the edge. And it also has a wider field of view than the typical eyepiece when you look through it. So it's a lot easier on your eye in terms of eye relief, looking through the eyepiece to see the object. I love these little flat field eyepieces. I think they're the best. You can spend more on them, but they make them for this one here, $70. It's not that expensive. And this is something you can add as an accessory. Once you have your telescope, when you buy them, you usually get two eyepieces that come with it, but these are going to be a lot better and more fun to use. You usually have one that's 27 millimeters or so, and then you have one that might be between 8, 10, or 15 millimeters, which is a smaller eyepiece, more powerful, so that you can get closer to the object. What else do we have on the pictures? This is a Rigel finder. And for some of the mirrored telescopes, some of the telescopes I was just talking about, typically the finders that they send you with the telescopes are not that good. I think these are a lot better. These finders, there's two of them. There's Rigel and Telrad. This is the Rigel. And basically it works with an illuminated reticule. Looks like a bullseye that you can see the background of the sky with. So you look through the back of it, and you can see the background stars and sky with the little red circles that are like a bullseye. And you can control the intensity, how bright or how dim the circle is with a knob on the thing. You can also align it with the three screws so that you can center it, what you have in the eyepiece. And typically, if you want to center a sight scope, just use a street light, a distant street light. So it's just a dot, just a street light. Get that street light in the eyepiece, and then get the finder on the eyepiece, and you'll be centered up. If not that, the pole star. If you can find the North Star, use that because it doesn't move, so you can keep it centered. The next object that we have, it might be a Telrad. Let's see what it says here. Yes, this is the Telrad, and you can see it's mounted on the telescope, and that's what I was talking about, those concentric red circles. So you can see the background of the sky and the stars through the finder, and you have the red lines, the red circles on there, and that's when you want to get your bullseye lined up right with it. The Telrad has a longer base, so if you have an optical tube for your telescope, you want to make sure it's not too short, because the optical tube, the Telrad is longer. The Rigel is up and down, so it's only got a very small base. They double stick tape to the tube, and I mean they stay on there really well. So both of those finders just double stick on. That's it, and you clamp them on there, and you're done. The Telrad is the industry standard for astronomers to use, again, because it's so easy, it's so practical. It works off AA's, which last about 100 years, and it's got the 3 screws to align it. It's got a dimmer switch on the side, and you're off to the races. And these are some of the better ones, as long as the optical tube of your telescope is long enough to fit it, and most of them are. So a very good finder to use as an accessory. It's worth the money. It's worth it makes your finding things a hell of a lot easier. And again, use either the North Star or a street light that's way off in the distance that you can get to align the telescope so that it's centered in your eyepiece as well. Yeah. What's next? Let's see what I have here. Oh, this book, 110 Things to See with a Telescope, is a very good beginner's astronomy book for people who are just starting out. They love using this. So I wrote the foreword in this book, actually. And it's a really good book. It's great because it explains everything to people who are just starting out and gives you all the basics and all the do's and don'ts and all the tips and things and all that. So it's a very good book, and I would suggest getting that as well. Just if you're getting ready to start out and in pursuing astronomy. The next, let's see. Is there any more? Is that it? I think that's it. Right. Well, then I guess we can open it up to questions. Yes.
Yes, that was the last one, Tim.
Very good. All right. Cool.
We good with question and answers now?
Good evening, Mr. Russ.
Yes.
I was kind of curious. You alluded to it, but we noticed in all of the unistellar photos, it listed how long each of the exposures was.
Yes.
Were those all taken in the LA area? Because I was kind of curious to what the border level was in some of those photos. Or are they all taken at the same place?
The majority of those pictures were taken right in my backyard in the city of LA. There might have been one or two that were taken out in the dark skies. Typically, the ones that I image in dark skies are the objects that are more faint. They have a magnitude of, +9 or greater, and so they're really hard to. Those are harder to bring in inside the city. The Rosetta Nebula is one of the examples of it. It's really hard to bring that into the city because the surface brightness of those objects is not as bright as others. So I'll typically, a lot of those that I just showed you, several of them, if not most of them, are taken within the city. Andromeda, the Whirlpool, all those are taken in my backyard. The asteroids too. The asteroids are all done right in the city.
So speaking of your backyard, we all have neighbors who have the latest, greatest floodlights. How are you doing?
I don't have any floodlights in my backyard. I've got a high fence and trees everywhere, so no problem. I cannot see any lights in my backyard. So I turn everything off in my backyard. It's pretty dark. But I've imaged some things with a 3/4 moon up and still been able to get them. So again, when the objects that I primarily go for in my backyard, the magnitudes are going to be somewhere around 3, 4, 5, somewhere in there. I typically, when I start to get over 8, 9, 10, I usually don't bother with those until I have access to dark skies. I could do it. It just takes a lot longer to get the image, and it's not going to be as bright or detailed as I can get in dark skies. So most of these objects that I showed were objects that have great surface brightness, and there's a lot of them I haven't imaged at all yet, just because I haven't gotten around to it. But there's quite a few that you can get in the city that are quite good. If you can also leave the telescope on the objects for a little longer to gather more light, get a little bit brighter. But essentially, it just depends on the magnitude of what you're looking for.
So in the chat, Tim, we got a questions.
Yes.
Did you get a chance to talk astronomy with any of the actors or staffs of the shows that you've worked on? Were others into astronomy or telescopes?
Nope, nobody else. It was just, I think I brought my little ETX Maksutov telescope there once just to look at the moon and maybe Saturn or Jupiter or whatever was up at the time. I brought it to the set and give everybody a chance to look through it. They were amazed at what they could see with that little telescope. But at the end of the day, I didn't really discuss astronomy with anybody else in the cast or the crew, really. They just had a chance to look through the telescope if I brought it by the set at the time. I was primarily the only one that was interested in pursuing it.
We got some unfortunates and sorry to hear that in the group.
It's not the most widespread pastime or hobby in the world. That's the way it works.
Right. When you started pursuing astronomy, what was your biggest struggle and how did you overcome it?
Well, the hardest thing was just learning the sky. It's learning the sky and being able to locate the objects that are in the constellations. Because when I started, I had to star hop. Basically, you star hop. You had to put the telescope up, look at the map, find the constellation, see where it's located on the chart, and then get the telescope sights over in that area, and then scan that area with the telescope until you could get the object in the eyepiece. It was particularly difficult with the very first telescope I started out with because the smaller, more faint objects were harder to see because they're not gathering enough light. So the very first things that I started looking for were probably out of the range of that telescope, the Astroscan at the time, the little 4-inch mirror. It's just not powerful enough to see those objects that clearly. So what's the best if you can manage? The book has that I showed you has some of the things, but what you want to get an idea of if you're using optical mirrors or lenses as a telescope, you want to see what the object you're looking for. If it's a deep sky object, you want to see what it looks like in the eyepiece so that you'll know when you get it in the eyepiece, you'll know what you're looking at. Otherwise, if you look at the photo from the Hubble or some magazine or some picture of it that's taken by a camera, it's not going to look like that in the eyepiece of your telescope. You're not going to see anywhere near that kind of detail or color. So in an optical visual realm, you have to see what that object might look like in your telescope before you look for it if it's a faint, hard to find object. Like the Andromeda galaxy, the image I showed you is an image that's been taken by the Unistellar. So the light's been stacked. When you look at it through an optical telescope, which is fairly easy to find, Andromeda is not hard to find. In dark skies, you can see it with the naked eye almost. But it won't look like that much detail, but you will be able to get it in there. And it will fill the eyepiece because it's really big. So you can see it, but you have to know what you're looking for. The double star in Mizar, the double star in the handle of the Big Dipper, is very easy to find. And you can see it once you get it in there. You should be able to identify it even with a small telescope, just as an example. So yeah, the hardest challenge is if you're starting out is locating objects that are more or less deep sky besides the moon and planets. The Pleiades, for example, is a very good object to look at with a wide field, low power telescope. And you can see that with the naked eye, especially in dark skies. You can see it with the naked eye, and you just put the sight on it and you'll get it in there. Those kinds of objects, the Orion Nebula, very easy to find. Orion shows up anywhere, and even in the city, it'll show up. You can see Orion in the city. So those types of objects you can look at with an optical telescope, a low power optical telescope, very easy to find. When you look at the belt star, the third star in the belt, or is it the second? My God, I forgot if it's the second or third, but look at that. You can find those in there and see them. So anything that's more difficult to find, you need a star chart. You need to be able to locate them. You have to know where the constellation is, to identify the constellation and make sure you're in the right place, and then put the telescope on that spot to try to find it. That's the trickiest stuff about just visual astronomy when you're starting out.
Similar question. What was your large astrophotography struggle and how did you overcome that?
There's not any astrophotography struggle because I'm using the Unistellar telescope. I did not pursue astrophotography. I never did. I've always done visual. When I began the presentation, I don't do astrophotography. I have no desire to do that. It requires thousands of dollars of equipment, and it's very meticulous, and you have to input a lot of parameters and figures in order to get this thing to work properly. They're not. I wouldn't bother. If you're going to do astrophotography, you might as well just buy the Unistellar and be done with it. It's one price, one telescope, no gear. It's just one thing. And you can actually image like that quick. Astrophotography requires hours, 3, 4, 5 hours a night. You have to stay out there all night. And then you have to go out there the next night and do the same thing for another 3 or 4 hours. It takes forever to get an image doing traditional astrophotography with a CCD camera and a very expensive telescope with really expensive glass and a guide system. All that has to work, man. And hopefully Elon Musk's Starlink won't come zooming through your exposure and mess up the whole works. The EV scope does it in 3 or 4 minutes. So you're less likely to have asteroids or planes or whatever coming through and messing up the whole thing. That's what I would do. That's my suggestion. You can go through all the hassle of doing serious astrophotography, but I don't do with it.
Our big imager here, we got to go get a defibrillator. We'll be right back. Okay. Unistellar still partner with SETI for the citizen science projects.
That's great. I know Seth. I worked with him a long time ago. He's very cool. Very nice guy. Yes. Any other questions? I think some people had some. Yeah.
Yeah. Did you get my last one? Did Unistellar still partner with SETI for citizen science projects?
I do. Yeah, I think they did. I think they are still partnered with them. I haven't checked in for recently. I haven't checked in to see what citizen science is offering. Even on my system here, I haven't looked in it for a little while. All we've had is crap weather, for the last month. So I haven't had a chance to check in. I will. I will do that. I'll email them probably this week and see what's going on. They have a brand new scope, the Odyssey. I'm very interested to see what, if I can get my hands on one of those, because I want to find out what they've improved on as far as the parameters and things. The EV scope 2, which I own right now, is probably going to come down in price because it's last year's model. It's like the iPhone, right? And they're only going to keep producing more of these. They're only going to keep making them better. And other companies are going to throw their hats in the ring as well. Some have already done it, but most of them don't have eyepieces like this one does. The key to this telescope is the eyepieces. If I'm doing a public star party, an outreach, people want to look in the eyepiece, man. It's that simple. You can have it on your cell phone or your laptop or what. They don't give a rat's ass about that. They want to see it through the eyepiece. That's organic. That's far more of an emotional impact on the viewer to look through the eyepiece and see this object with your naked eye. That's what's happening. And I told them as they're designing the next generation of this telescope, I said, leave the bloody eyepiece on. Not only is that eyepiece, it's nice to look at that eyepiece, it actually is a very wide field. So you could look at that eyepiece and be an inch and a half away from it with glasses on and still see the object. It's amazingly wide field, far more than traditional eyepieces are. So it's very easy to see and watch through that eyepiece. I'm glad they designed it that way. They worked with Nikon, I think, on the eyepiece. Yeah, Nikon. So it's really nice.
Hi there. I had a question about the asteroid occultation.
Yes.
What did they use? So you said that they took that data for Lucy. What exactly did they use that data for? And
They wanted an approximation of what the asteroid shape was.
okay,
So they actually showed me the model. They had a small model made out of that was printed on a 3D printer of this asteroid. Sort of an oval. It was an oval shape, but kind of flat. It wasn't like round. It was more of a flat sort of oval shape with beveled edges. And they showed it to me a little while ago. I was able to see it. But they wanted to get an approximation of what the shape of the asteroid was, what it actually looked like in terms of its edges and its size and that kind of thing. So that's what they wanted it for primarily.
cool. Unrelated completely. I'm also a musician, and I'm just curious, what instrument do you play?
It's the guitar. I've been a guitarist for 50 years. I play lead guitar, rhythm guitar, bass guitar, but mostly lead and rhythm. And I front my own band as a vocalist as well. So I've been doing that for a really long time. I own at least 3 of them, as we tend to do. We tend to have more than one. So yes, I play a Stratocaster and 2 Tellys. So. Was there other questions?
Can you hear me now?
Yes, yes.
Hi, Tim. I just had a question on in your 35 years, have you ever gotten to travel to different destinations to view stars? And if so, what were those really interesting destinations that you've been to?
Thus far, I have not traveled with my telescopes anywhere to look at any of the other objects. I did go to Puerto Rico, and I was able to visit the radio telescope there. That was fascinating. We didn't get a chance to see anything with them at the time. It was a daytime sort of thing visit, but I was able to see the scope and the radio telescope, and I was able to talk to one of the scientists there, the astrophysicist who was studying at the time a pulsar, which is of course a collapsed star that spins around really fast and releases very precise and very rapid pulses. So that was very cool to be able to do that. To visit that observatory and see the telescope at Arecibo. It was very cool. That thing is absolutely ginormous. But otherwise, I haven't taken my telescopes anywhere. I'm going to go to the total eclipse coming up in April. I'll only be taking my binoculars to that. I've got 2 sets of binoculars. I'll have one set with the Mylar glass filters on them, and then the other set without. And so when we get totality, I'll have, you know, naked eye viewing and some of the viewing without the filters. But that's all I'm taking is a couple of binoculars. So I want to experience the whole thing as it's happening, you know, without looking through a telescope. And I'm not taking any pictures because everybody's taking pictures. So that's all the pictures would look the same. So there's no point in me photographing the thing when I'm standing there, you know, with, you know, everybody's going to have the same image, you know, that I could take. So it's not going to be any different for me. I just want to experience it live, you know. Next question.
Did you do any drawings before you got the unistellar scope to take pictures with? Astronomers back in the day used to draw what they saw.
I did not, because I'm terrible at drawing, man. I can't even draw stick figures. No, I was not drawing. It was just, let me look through the eyepiece, let me see it, let me enjoy it in real time and moving on. And that was it. I didn't even attach. I think one time I attached my, one time I shot, I did one picture with, I piggybacked my Schmidt-Cassegrain telescope, which had a motor drive on it. So I piggybacked my DSLR camera onto the back of it. And I did get an image of the North American Nebula because it's very faint, but I got a pretty good image of that. I think that exposure was about 11 minutes. And I had some pretty fast film in there. And I got a picture of that, the North American Nebula. And I think I got the veil also, just by piggybacking it on the back of my Schmidt-Cassegrain because it was tracking east to west. And so we could hold it pretty steady. And I got 11 minutes of an exposure, and I got, you know, the color of the reddish color of that nebula. That was it. That was the extent of my my astrophotography because it was fairly easy to do. It didn't require any extra gear. But, you know, to me, it was, again, it's visual. I just like the visual of astronomy. I like being hands-on. Let me look at it. Let me see it, you know.
Hello, thank you very much for your information, and it's live long and prosper. And I was wondering, are you all, this is all self-taught? Did you take any courses along the way? And do you
Nope. No.
taught?
No courses. No. It's all self-taught. And hey, listen, I didn't have Google when I started. Google didn't exist. There was no online anything when I started. So now, for all of you, anybody who's starting out, I could sit here and talk for 10 days straight, and it's not going to equal a fraction of what you can find just by doing this. Everything you can conceive of and imagine as far as information is online. Just type it in, read it, check it, go to the forums, go to the sites, get the feedback, get the reviews. If it's a piece of technology you want to buy, if it's a telescope, if it's a finder, if it's a whatever, just type it in and get the feedback, get the information on it, see how it's used. You know, you want to find out how to go locate something over here or what this looks like over there. You want to see what the images will look like in the eyepiece of a small it's all online. Everything is online. All the research that is at your fingertips, literally, which I did not have. I didn't have any of that, man. All I had was some star charts. That was it, you know, and they actually made star charts for the Telrad finder, which is very handy. Those are just plastic laminated charts. It shows you the constellation, shows you where to put that bullseye that you were looking at earlier. And all you have to do is put that bullseye where it says on the chart. That's what I did. And you can use that even today. But you have access to information that I did not have. So everything I did was basically on my own, you know. I read a couple of, you know, I had a couple of beginners books at the time that I used, but mostly it was star charts and just sitting out there, you know, looking for stuff. It's much easier today, I think, than and obviously when I started out, much easier.
So,
yeah.
Tim, we have a couple more questions, but I did want to tell you, you took the wind out of my sails because one of my questions was going to be, has any of your astrophotography ever been used in any of the shows you've got? And you've killed astrophotography. So I love it.
Any of the shows, which you mean the shows that I've been on?
Yes, sir.
Oh, hell no, no, no. They didn't. Yeah, they would get their they would just get their images off of Getty or something. They're not gonna get them from me. No, no. I haven't even, I've done some episodes of projects I've been on as an actor having to play guitar. Referring to the other gentleman's question about playing music, that has crossed over a couple of times. I worked on Crossroads with Ralph Macchio. I had to play guitar, blues slide guitar on that. And I also had to play in an NCIS New Orleans episode, having to play guitar live. We actually filmed it live. So that crossed over. Thus far, nothing in astronomy have I been able to use in terms of acting. You never know, though. That could happen tomorrow. I could get a call to do a project tomorrow where I'm required to either use a telescope or talk about it or actually put an image in. You never know. It could happen tomorrow.
The unistellar scopes.
I don't mean to, I don't mean to mean, using astrophotography. I'm just not, that's just not my thing. And anybody else can do it. I mean, you guys do it or whatever. You can choose to do that if you'd like. I just don't do it. It's to me, I'd rather just do it simply. Like rock with a light switch, rock, light switch. That's just me. So if it's easy to do, that's the only way I do it. And the unistellar imaging scope, it's one price, one fee, and I'm done. And it's just simple. That's just me. Anybody else, man? As my buddy says, have at it, hoss. It's all good. Yeah. You were saying?
One of the questions was that the unistellar scopes are fine smart scopes. What do you think about the increase in the number of similar smart scopes now available?
The other ones don't typically have an eyepiece. The Stellina, and there's 2 or 3 others that are very small, compact. You can put them in a backpack. You sit them on the ground. Their exposure time is upwards of 45 minutes to an hour. So they're going to take longer to get their exposure. It's also going to work with the cell phone app. It's going to download to the cell phone and bingo. You can use those as well if you just want to do astrophotography. The imaging software in there is not going to be as sharp as what you see online by professionals. That what you see with a full-on astrophotography setup with hours and hours of exposure time, it's not going to be that sharp. It's not going to be that pretty, but it's going to be nice. It'll be nice. It'll be comparable to what I can get in the unistellar. Maybe a touch better because it's a longer exposure, but you don't have the eyepiece. So if you just want to do astrophotography, I think those telescopes run anywhere between $2,000 and $3,000, and they're small. Like I said, it's a backpack. You could put it in a backpack. You sit them on the ground, you crank them up, tell them where to go, and sit it out for about 40, 50 minutes, and it'll download to your cell phone, and you are doing astrophotography. That simple, that easy. So yes, there are 2 or 3 others out there. I know Stellina is one of them, and there's 2 others that are just come out recently. They'll do it. I just like the unistellar because it has an eyepiece. That's it right there. People want to look through the eyepiece. I do public star parties at Griffiths Observatory here in Los Angeles. There's hundreds of people that come by there because there are tourists coming into the observatory. And we've got, 25, 30, 40 telescopes on the front lawn. And all anybody wants to do is line up and look in the eyepiece, man. Okay. From the kids to the adults to whatever. They just want to look through the eyepiece. So,
So I've got 2 more questions, one in the audience and one on chat. I have one person said that they love the visual aspect of looking through the scopes. Any chance of getting a unistellar coupon?
Well, if that was the case, I'd be trying to get one as well. I don't know if they have coupons. They do have a sale though. They do have sales on those scopes from time to time. So I would check and look at the Unistellar 2 because the Unistellar 2 is last year's model. It's the one that I own now, which will probably come down in price somewhat because of the new one is out now. They're trying to sell the Odyssey, and the Odyssey I'm sure is going to be more expensive. So you might be able to get the Unistellar 2 at a reduced price. It's still going to run you, $2,000 or $3,000 at least to get one, unless you buy it secondhand. But those are, that's what's going to happen. It's like a cell phone. Every year the next one comes out, the other ones are going to be a little less. So I would keep my eye open about there on their website, see what they got selling, see if anybody's selling a new one on eBay or one that's relatively new on eBay for a deal. Get to look at there as well because they might be out there. But yeah, they're good, and their support's pretty decent. They'll get back to you, and they've got all the instructions and manuals and all that stuff for stuff you can do, and they'll get back to you and they'll let you know what's happening in case you have any issues with it. It works pretty well. All the computers are just like the computer you have at home, man. So sometimes they have quirks and glitches and things like that. That does happen. It's happened with this one every once in a while. It's like any other computer. They're computers, basically, is what they are. That's what drives them. There was another question.
Okay, so this is apparently the last question. I was kind of curious. At least one member of our club actually has a Unistellar, and I got to look through it, I don't know, a year or two ago. And you mentioned that you're a visual only astronomer, and I'm the same way. I just like the photons actually hitting my eye. But well, pardon me. But so I'm really kind of curious. When I first looked through the eyepiece of the Unistellar, it was clear that you were looking at a screen. Does that bother you, or did you eventually get over that?
Oh yeah, that doesn't bother me. That it's basically you're getting a projection from the imager. That's fine. It doesn't matter to me, and it darn sure doesn't matter to other people that look through the eyepiece because they are absolutely blown away. I've been blown away just looking through it. Yeah, it's not the same as looking at a mirror, or a piece of glass. The star points aren't going to be the same as they will be in an optical telescope. That's absolutely true. You're not going to get that sharp twinkle edge on a star that you'll get in an optical telescope. But you have, like I said, you're able to see mostly what you're looking for in that unistellar are diffuse objects. You're looking at objects that are cloudy, that are fuzzy, that are diffuse. So it's a galaxy, or if it's a nebula, things like that. That's primarily what you're looking for in terms of this telescope. That's what it does. It is not designed to look at planets, not designed to look at the moon. You can pinpoint Uranus and Neptune. You can see it in this telescope. You can get it. Not easy to find that in an optical telescope, but you can get those two things. They're not going to be sharp and crisp like they might be in an optical telescope if you can bring them in. So you're going to have a little bit of that sense when you're looking through it. But the idea is, from the images that I showed you here in this particular presentation, that's what you see in the eyepiece. And I don't know, to me, I have no problem with the fact that it comes off in the eyepiece the way it does. Absolutely none. The fact that I'm able to see it at all with that kind of detail, naked eye, to me is absolutely stunning. The very first time I looked at it, the first thing that I saw was the Dumbbell Nebula, and I couldn't believe it. I just couldn't believe it, and that was up in the middle of the city. And that I was sold at that point. I said, there's no way. I've seen the dumbbell 100 times, 1,000 times in an optical telescope in dark skies, and that's nothing compared to this with color, no less. I mean, color? No way. If it appeared to be on a clay tablet, I'd still be happy, with that visual.
Okay, I lied. We have one more question in that
No
last.
worries. No worries. Got time.
Well, thank you for speaking with us. My question is, what took you 35 years ago from just looking up into the sky to deciding you wanted to go into that deep dive, which is telescope viewing? Was there some incident or some reason?
You mean reason I started to do what I did? Man, it was just out of the blue. I've always been fascinated with space science and the study of astronomy. I've always been fascinated by space in general and the cosmos and the discoveries that people have made and things like that. I just wanted to participate in it hands-on. I mean, the planets are up all the time, and I had not looked at them through my own telescope. Matter of fact, I hadn't looked at them through anybody's telescope ever before. And so the first time that I looked at Saturn, which was the very first object I looked at was Saturn, I was done. I was hooked. So it was just a desire to actually look at that planet naked eye. And again, it's the visual aspect of looking at Saturn with the naked eye. There's no photograph that can really ever match that. You know, it's like a photograph. Who cares? It's seeing that object with a naked eye for the first time was an absolute thrill. And it was tiny because I had a very small telescope, but I could see the rings. I could see it floating there, you know, in the blackness. And it was just stunning to see that through an eyepiece. I was done. I was hooked. I was done. I was going, and I haven't stopped. So that to me is what it was. And it was nothing. There was no particular incident that motivated me to do that for the first time. I just did it. I just decided to go do it on my own. There was nobody even with me when I did it. I was just on my own.
Cool. Well, thank you so much, Tim, for all your time today and answering all the questions.
Yeah,
I think that's all we have for you, and we really appreciate you joining us this evening.
it's my pleasure. And you guys recorded all this, so you can look at it back, or I guess show it again, or do whatever you had to, if as far as the information goes.
Sure.
So that would be great. Yeah, so you could have that. And I wish everybody all the best, and thank you for having me. And I hope that some of you are able to get some equipment and get some hands-on viewing, whether it's a small tabletop Maxudov or whether it's a Unistellar. Either way, I hope that everybody gives a chance to actually get some hands-on participation in all this. Yeah,
Thank you so much. Really appreciate it.
you got it. Thank you very much for having me, guys. Thank you.